What if the most productive developer on your team only works while you sleep, costs almost nothing, and, well, isn't human?
Yeah, that's the dream, right?
Seriously. Welcome to the Deep Dive. Our mission today is to explore this massive shift in how we actually interact with artificial intelligence.
Right, because we're moving away from treating AI as just a really smart autocomplete function.
Exactly. And we're transitioning to deploying it as a literal, autonomous, nighttime employee.
And we are basing this whole exploration on a really fascinating DV community article.
Yeah, it's by Alexander Tutin.
Right, written for the Google Developer Group. The piece is called Morning Security Report with Antigravity Agent.
And this surfaces right after those recent Google Next updates, right?
Yeah.
Where they fundamentally restructured their whole AI ecosystem.
They basically took the anti-gravity agent and the anti-gravity IDE and decoupled them into two totally distinct applications.
Which is huge. And out of that structural split comes the specific feature we are unpacking today, which is scheduled tasks.
Yeah, scheduled tasks.
And when you read through the source material, the way Alexander leverages this scheduling feature, I mean, it requires a complete reframing of how we manage our digital resources.
Oh, totally. But to really understand the technological leap here, we have to look at the financial constraint that actually drove it in the first place.
Right, because true innovation usually starts with someone trying to stretch a dollar.
Exactly. So Alexander is operating on the most affordable paid tier for anti-gravity.
Which has some pretty strict limits, right?
Yeah, it enforces a rolling 5-hour limit window for usage.
And that billing mechanic, that 5-hour window, that is the catalyst for this entire project.
It really is. Because the timer starts ticking the absolute millisecond you send your first prompt.
So just to be clear, if you query the model for like a really quick syntax check at 8:00 a.m.
Your window slams shut at 1:0 p.m.
Wow. Regardless of whether you've been actively coding or, I don't know, stuck in product meetings the entire time?
Exactly. If the model sits idle, the clock still runs.
Okay, let's unpack this because that's intense. It's basically like running your dishwasher or doing your laundry at 2:20 a.m. to get off-peak electricity rates.
That is a perfect analogy. You start looking at LLM compute resources the exact same way industrial facilities look at off-peak power grids.
You don't run the heavy machinery during peak daylight hours when the resource is constrained.
Right. And Alexander applies that exact load balancing logic to his AI usage. He pushes all the token-intensive, time-consuming security scripts to run asynchronously
While he's asleep.
while he is fast asleep.
So the agent spins up, burns through that whole 5-hour limit running these deep code base analyses, and then just shuts down in the dark.
Yep. And then, when he opens his laptop the next morning, he triggers a completely fresh 5-hour block for his active manual workflow.
That is honestly brilliant.
It's a fantastic application of FinOps financial operations, but at a purely personal level.
Right, it's not just some corporate dashboard.
Exactly. He's maximizing his personal ROI by ensuring the AI's heavy computing hours physically cannot overlap with his own creative working hours.
So he doubles his output capacity without having to upgrade his subscription tier.
Which is just smart.
It really is. But, maximizing cloud spend is a great practical hook. But as you dig into the mechanics of the article, preserving that compute block isn't even the primary victory here.
No, it's not. The actual bottleneck in software development is cognitive load.
Exactly. Saving money is great, but preserving mental energy is the real currency for a developer. And here we hit this fascinating paradox in the source material.
Oh, the fact that he's a security guy.
Yeah. Alexander is a cybersecurity professional by trade, yet he actively hates doing security reviews when he's building his personal project.
Which sounds crazy, but it makes total sense. The context switch is just brutal.
Right, because when you're building a feature, you're in this generative flow state.
Yeah, you're creating. To stop, pivot, and analyze your own architecture for vulnerabilities, that requires a completely destructive mindset.
You're suddenly trying to break the castle you just spent 3 hours building.
Exactly. So to eliminate that friction, he relied on a progressive automation strategy, basically a Kaizen approach, continuous improvement.
Right. He didn't just build this overnight.
No, he initially built an anti-gravity workflow to automate just the initialization of security checks.
Okay.
And then later, he deployed an AI quality gate hosted on Cloud Run to review his new merge requests.
And the architecture of that quality gate is a really clever stepping stone, honestly.
Oh, it's great. He configured Cloud Run to listen for webhook events originating from his repository.
So a new pull request comes in, the webhook triggers Cloud Run to spin up a stateless container.
Yep, and that container passes the code, diffs to the AI model, and the model posts a review back to the repository.
But the core problem remained, right?
Yeah, the cognitive load was still there.
Because he still had to sit at his monitor, read the AI's feedback, parse the severity of the vulnerabilities, and then manually write the patches during his daylight hours.
Right. The tools were definitely sharper, but he was still spending his valuable developer time acting as a security guard.
He had optimized the reporting, but he hadn't removed the burden of the actual remediation.
Which is where the nighttime agent comes in.
Okay, but I have to push back here for a second.
Sure.
I hear the efficiency argument for taking the human out of the loop, but giving an AI unsupervised write access to your code base in the dead of night. That sounds like the start of a sci-fi disaster movie.
It does sound terrifying, yeah.
Like the potential for an AI to hallucinate and nuke a production database while you're asleep is a massive structural risk. Isn't that super dangerous?
Well, what's fascinating here is that risk aversion is exactly why the scheduling feature changes the paradigm.
How so?
Think about it through the lens of writing a book.
Okay.
The previous webhook setup, where it reviews your code as you go, is like having a tutor looking over your shoulder, tapping the screen every single time you make a typo.
Oh, that would drive me crazy.
Yeah.
It completely interrupts the flow.
Exactly. But the scheduled autonomous agent, that's an editor. You hand over your messy, rough draft at midnight, and the editor returns a clean, structurally sound manuscript in the morning.
Ah, I see.
By scheduling the deep review, Alexander silos the destructive testing phase entirely away from his creative phase.
So he wakes up to a clean slate rather than a massive backlog of technical debt.
Precisely.
Okay, but to see if this editor analogy actually holds up in practice, we need to look at the real-world results he got.
Right. Let's look at the actual project highlighted in the article. It's a repository called Your ROI.
Right. He configured the Antigravity Agent to run a comprehensive architectural and code-level review overnight on this specific repo.
And the findings were pretty significant. The agent uncovered critical vulnerabilities, specifically highlighting server-side request forgery, or SSRF, and several insecure network configurations.
And just for context, when we talk about an AI identifying an SSRF vulnerability, it's finding places where an attacker could basically manipulate the server into making unintended requests to internal resources. It's a big deal.
It's a very big deal, and the agent doesn't just flag it. It generates a full threat severity matrix to categorize the impact.
But here's where it gets really interesting. The ultimate payoff isn't just the report. Alexander instructs the agent to actually implement the fix.
Yeah, that's the magic trick.
But how? How is it executing that patch autonomously without just completely breaking the build? Like, is it forcefully pushing code to the main branch?
No, you definitely don't want that. A robust implementation requires the agent to generate an isolated branch first and systematically enforce network boundaries there.
Okay, so it's safely contained.
Right. For an SSRF patch specifically, the agent has to identify the vulnerable outbound HTTP call and rewrite the underlying function to validate and sanitize any user-supplied URLs against a really strict allow list.
So it actually has to write the rejects, ensure internal IP blocks like cloud metadata endpoints are explicitly denied, and then commit that sanitized logic.
Yes. And it actually resolves the blockers, updates the repository documentation to reflect the new architectural changes, and presents a completely green passing code base.
Well, all before he even pours his morning coffee.
Exactly. And this capability, it fundamentally shifts the developer lifecycle. We are moving away from just hacking together a local MVP.
A minimum viable product, right?
Right. And we are moving toward a fully automated developer pipeline where the AI serves as both the penetration tester and the remediation engineer.
So the human's role really transitions from laying all the individual bricks to just inspecting the structural integrity of the wall that the AI built overnight.
Beautifully put. You change from creator to reviewer.
Now, with a workflow this perfect, something that dramatically alters the whole software engineering lifecycle, you would expect a massive community response, right?
Oh, for sure. Developers usually flock to anything that eliminates tedious tasks.
Exactly. But if you look at the bottom of the DEV community source page, there are 0 top comments.
Nothing.
It is a completely empty room.
Yeah, that silence is really telling. It highlights this persistent gap in how AI development workflows are actually shared online.
What do you mean?
Well, the triumphant end results, the screenshot of the 100% green repository, the fancy severity matrix, those are highly visible and easy to share.
Right. Everyone loves a good success screenshot.
But the granular, messy configurations that actually make that automation safe in the first place, those are frequently glossed over or just left out completely.
And case in point is the system prompt itself.
Exactly.
In the article, he actually includes a header that says bonus, the prompt used, but the actual text of the prompt seems to be missing or obscured or maybe lost to some formatting error.
Yeah, it just trails off into unrelated sponsor links.
Which is crazy because if someone listening wants to replicate this nighttime editor, they need to know exactly what technical guardrails to put in place.
This raises an important question about transparency in these AI communities. So let's actually engineer what that prompt needs to look like to prevent that exact disaster scenario you mentioned earlier.
Right, because if you simply command an agent to, quote, fix all security bugs and leave it totally unsupervised, you risk massive scope creep.
Oh, absolutely. The AI might just hallucinate an entirely new, incompatible architecture because it thinks it's, quote unquote, more secure.
So you would have to prompt it to isolate state changes. You'd need a hard directive commanding the agent to strictly avoid modifying database schemas, right?
Yes. Or altering external API contracts unless it explicitly requests human authorization first.
And you also need to enforce test-driven development within the prompt itself, don't you?
That is crucial. A robust guardrail would mandate something like, before implementing the SSRF patch, write a failing unit test that actively exploits the vulnerability.
Okay. Prove the bug exists.
Right. Then apply the patch. Ensure the test passes. If the test fails, revert the change entirely.
Wow, that prevents the agent from simply deleting the vulnerable function just to clear the error message.
Exactly, because deleting it would completely break the application's core functionality, but to the AI, hey, the error is gone.
Right, the AI is like problem solved, but your app is dead.
Exactly.
But even with a perfectly engineered, highly deterministic prompt, how does the system handle massive multi-file refactors? Because Alexander notes in the text that large changes require a lot of time.
Well, a scheduled task attempting a sprawling architectural change at 4:00 a.m. is inevitably going to run into token limits.
Or context window degradation.
Right. The agent might successfully patch the authentication module, but completely lose the thread of the application's overall logic by the time it reaches the routing functions.
Which makes the mention of open code in the article sidebar so relevant.
Yes.
There's a link pointing to a tutorial on using open code as a fallback agent for anti-gravity. The implicit admission there is that the anti-gravity agent sometimes just fails mid-task during the night.
And that is the reality of it. The orchestration of fallback systems actually becomes the primary engineering challenge of autonomous workflows.
So what happens if it fails?
Well, if the primary agent hits a timeout error or a token limit crash, the fallback agent has to be capable of waking up, reading the Git history, and understanding the incomplete state of the code.
Oh, man.
And then making a deterministic decision to either safely roll back that broken commit or try to finish the implementation.
That is wild.
Yeah.
You're basically building complex safety nets for invisible workers.
You really are. The theory of the autonomous nighttime employee is incredibly appealing, but the operational reality of managing stateful recovery, that is where the actual engineering happens.
You can't just flip a switch. Implementing this requires testing all those guardrails in a heavily sandboxed environment before you ever grant an agent right access to your production code.
Absolutely.
So connecting this all back to you listening right now, whether you manage complex data pipelines or write backend microservices or lead a product team, look at your own daily responsibilities.
Yeah, ask yourself, what is the equivalent of a security review in your professional life?
Right. What is that specific, vital, but high-friction task that just drains your cognitive load? The one that pulls you out of your optimal flow state and forces you into a mindset you actively hate.
Because the blueprint provided by Alexander Tootin goes way beyond just a clever FinOps trick for Google's anti-gravity agent.
It really does. It's a master framework for defining a tedious task, building strict operational sandboxes, and scheduling an agent to handle the heavy lifting asynchronously.
Exactly. So you can preserve your mental energy and your creative focus for the strategic decisions that only a human can actually make.
It's about working smarter, but on a whole new level. Because think about it.
Yeah.
If an artificial intelligence is running the architecture review, generating the threat matrix, writing the unit tests, and committing the actual SSRF patches before your morning alarm even goes off. Tomorrow, when you sit down at your desk with your coffee, are you still a software developer? Or are you just the manager of an invisible, highly efficient digital employee?